Rob Connor has over 20 years of experience in the fatigue and fracture evaluation of steel bridges. He is currently a professor in the Lyles School of Civil Engineering and the director of the S-BRITE Center at Purdue University. During his career, he has researched fabrication flaws, fatigue cracking, and brittle fractures, and developed repair strategies for structures for a variety of agencies, including state DOTs, rapid transit authorities, construction companies, and structural consultants. Please help me welcome Dr. Rob Connor.
Thank you. Well, appreciate everybody staying here till the end of the day for this presentation. Again, it's a great opportunity to talk about the S-BRITE Center, something that we have going on down at Purdue University. We're quite excited about it. At the university, you always need acronyms, so that's what S-BRITE stands for. It's an acronym related to aging steel bridges primarily. And so we'll give you an introduction to it. I don't have to explain to anybody in this room about the needs for this, about aging steel bridges, average steel bridge, and we're focused on steel at S-BRITE. The average age is 50 years. Now, I just was talking, I'm on AREMA Committee 15, which is the Steel Bridge Committee for the railroad side, and we were showing them around the center last week, and they were kind of envious because, 50 years is a new bridge for the railroad people. But, on the highway side, we have our share of aging infrastructure, so that we have those issues. The issues of a changing workforce, that a lot of individuals with tremendous knowledge, legacy knowledge, move on, right? They retire, they switch careers, whatever it might be. But the infrastructure stays the same, right? When people move on, the bridges they built 30, 40, 50 or more years ago stay. At least we hope that they stay. And so, we had an issue in Indiana on a bridge that was fabricated from a certain kind of steel, referred to back in the day as T1 steel. The T was not for terrific. It was a precursor to the A514 grades of steel. And so, we have those legacy materials, legacy designs, and so forth out there. Well, how do we continue to maintain those? Because although, at Purdue, and a lot of people research new materials and new designs, and that's all great stuff, all the risk is associated with what's built, right? Not what's built. And so we're kind of focused on that side of it. The other thing we kind of came to conclusion in Indiana was that the training, although NHI serves a great purpose, we kind of view that a little bit maybe as the calculus and physics, right? The base courses that you would need to take. And in Indiana, we kind of fell after putting our heads together that there was a need for maybe some higher level training. And so, does the training that exists readily available meet needs? And we thought, well, maybe there's some room for improvement. I'll talk about that a little bit. And then as we get into some other topics, we spend a tremendous amount of money on inspection. But we don't really know about the reliability of inspection. So I'll talk about a research project and one that Glenn Washer, who's here, an NCHRP project, as well as another study looking at how do we gain information on detection or probability of detection. Again, it's not what you find to be worried about, it's what you don't find, right? So what is the probability maybe of missing things? Now, I'll focus on the aspects of S-BRITE that I think are the cool parts, our training facility that's outside. And somehow we were able to convince Purdue to give us about 22 acres of property for an outdoor facility, and I'll show you a lot of pictures of that. But when I went to present this to the powers that be and to the Board of Trustees, they thought, boy, this is a neat idea, but aging infrastructure is more than just steel bridges, right? And I said, well, yeah, but that's what I've got money for, to develop a facility on aging steel bridges. And they said, well, it'd really be neat to look at other materials or pavements, anything aging in the infrastructure. So the Center for Aging Infrastructure is really what I'll show you pictures of, but S-BRITE is considered like a user. It's under the umbrella of the Center for Aging Infrastructure. And our hope in our master plan that I'll show you is to include other aspects of aging infrastructure as we move forward. And so the grand vision, the 40,000-foot view, we think we've put together over a couple of years now a pretty unique place focused on aging infrastructure and how to extend the life. And so right now we're in the steel side, but hopefully down the road we'll expand to other materials. So where are we today? Well, Indiana obviously took the lead in the center. Made major commitments to develop the facility I'll show you, but also funded projects to keep the place going. had these short courses that I'll talk a little bit about. Some people in the room have taken some of our courses from the partner states. Another acronym, at the university, we want those, right? So we came up with this idea of the DEN, the Distributed Expertise Network. I'll talk about that. And then our outside facility, which is now developed. However, it became apparent that the problems we have in Indiana, or the needs, I guess I should say, are kind of common to all state DOTs, right, with aging infrastructure. And so we have several states who are on board as partners of TPF 5281, a pooled fund study, and I'll talk a little bit about that. We have commitments, at least verbal commitments, from Utah to join the center, as well as the Army Corps. And we're always looking for more partners. And what we envision is sometimes maybe a state would partner for a while and get some benefits, maybe come out for a while, maybe then jump back in, right, as they have training needs and whatnot. But it's meant to be very flexible in terms of what we can provide. And so it literally started on my desk with a sheet of paper, kind of drawing up this idea that, when we have an old structure and we take it out of service, we take pictures of it, we put it in PowerPoints and say, yes, see, there was a crack, or there was some corrosion, or some kind of bad detail, don't do that, here's a picture. And I guess my idea was, well, why don't we keep some of those things and use them for training purposes, where we could walk out and teach individuals, put their hands on something. Now, in this room, we're focused on, say, professional training, but we also hope to be, grooming the next generation. So for our undergraduate classes and graduate classes, we utilize the same specimens I'll show you. So it went from a sheet of paper, this piece of property produced that might be available, to then developing a master plan, in which we would have just various pads, basically gravel pads, at least at this stage, where we would put specimens, or we would lay down pavement. Now, the master plan has a training facility and so forth, but we're not at that stage yet. Today, what we've developed is what we would say is our north half here. And there's high voltage lines. We've developed north of the power lines, but we have the whole basic southern half yet to develop that's still available to us. So then it went from that to basically what you would see today if you went out. In fact, the power lines are off to the right in the photograph there. Basically, some people will say it's the rusted bridge gallery. No, you can't say that. It's the bridge component gallery, right? I have to have a better name than that. But what we've been able to do is acquire entire bridges and portions of bridges to use for training, research, educational purposes. So, for example, we were able to get from Michigan, from Calhoun County, an entire 90-foot span through truss bridge that we then re-erected ourselves. Everything I'll show you, we've erected, actually, ourselves. And so this bridge has various details on it. It's got corrosion on it. And so imagine then coming out and having undergrads or grad students, but also for professional training, to have access to a structure like this without worrying about traffic control and fall protection and things like that, to use in the training environment. Now, I'll use it for training and fatigue and fracture issues. However, my colleagues who might want to do things with drones, and they want a specimen that they don't have to worry about traffic control in drones, or documenting what's wrong with the structure, it can be well documented because it's ours, we can use it for that, right? If we wanted to do some proof testing of maybe some UAVs or something. We're going to use this maybe in structural analysis. So we'll strain gauge it and apply load to it, and so the students taking structural analysis courses. But a lot of these specimens will be used by different individuals. The state of Minnesota has been very generous to us. They're one of our partner states, and working to provide some specimens. These are girders from the Lafayette Street Bridge in Minnesota. Now, my area is kind of fatigue and fracture. This is one that my advisor, John Fisher, I remember having him talk about. It's had a full-scale fracture in the girder, and actually that's the girder with the fracture. It has basically hone type details, if you're familiar with those. And then the retrofit girder, which is near us in the left-hand portion of the picture. And so we have these full-scale specimens that we're able to examine and talk about. And the discussions that get going around these things are much better than what ends up happening in the classroom. Now these were our big girders. These are about 12 foot deep, and they're very large. And so when we bring people there and they stand by these, they're like, wow, these are huge plate girders. And they are. And they were, until we talked with Kevin Western up in Minnesota and found out that the Dresbach Bridge was coming out of service. Now, Dresbach had some really big girders. Big girders as in 22 foot deep at the haunch. And Minnesota and Ames Construction were kind enough to say, yeah, we'll get you some of these. However, not only did we get the big girders and the details associated with them, in fact, we had to lay them long way on the truck. They were so deep, so it limited the length of girder we could get. Only a handful of bridges in the country that have girders this big. A very nice pin and hanger detail So you can imagine issues with inspecting pin and hangers, a series of bearings, a series of gusset plate connections, and so forth. So these are the big girders now. For scale, where Jason Lloyd is standing there, that flange is about 3 feet wide and 3.5 inches thick. Massive girders. So again, great components for us to have here. We also have 35W components. Now these would be used in our forensic type training. Most of these are still in storage because we don't want to put them outside. We don't have our pole barn yet, but some of the components are outside and available. We feel very fortunate to have received these because we have pieces and NTSB. We're the only university with pieces from 35W. So great pieces for forensic type evaluation type courses. The railroads have also been very generous. CSX has donated some pieces of a railroad bridge just outside of 30th Street Station in Philadelphia, an old truss from 1903. That has corrosion and section loss like I've never seen in my life. This was a top cord of this deck truss, so the trains were running right on that cord, and it was carrying full, Class 1 railroad load till the day they took it out. Excellent components to use for training, fatigue detailing, like what to look for. There's some funny things on some of these cords and welded attachments that shouldn't be there. Great components for training. We also have an entire railroad bridge. The bridge is from the 1950s. It's all welded, which is very odd for a railroad bridge from that period. Pennsylvania Railroad is where it spent most of its life, in Jersey City, New Jersey. Then it spent time out in Pueblo, Colorado at the research facility there, TTCI. Now we have 22 acres, which is impressive. They have 55 square miles. They have a giant train set. If you ever get a chance to go out there, I'd encourage you to do it. We were able to get rails and ties donated to it. It has a whole series of fatigue cracks in it, various details, hone details, retrofits, some fractures in it, all kinds of things in it that are very useful for training purposes. In fact, our rail component is something we're working on. We want to develop that more. At Purdue, we're boiler makers, and some of you may have seen the research we're doing on driving our own hot rivets for some tests. But we want to get our rail program back up and running, and so one of the things we're getting now, BNSF sent us some signals. We hope to put in some track with switches, actually. In our master plan, we have about 1,000 feet where we can put in paved road and railroad track. So we're hoping to get that a little more further developed. And a lot of other components, without getting into detail, again, that we use for the inspection and training portion of the center. Really, really fun to have these things. And again, I guess I can't emphasize enough, like the training environment, the feedback we get, and how many people here have taken one of our courses, just out of curiosity? So a few. Talk to these folks. We've gotten great feedback on the ability to, for these courses and what we have in terms of the specimens, and talk to the partner states because we think it really makes for a great environment. And training is a major focus. Now, I actually have to run back tonight because we're doing our Inspecting Steel Bridges for Fatigue course tomorrow and on Wednesday. But we have other courses. We have 5 in our sushi menu now that partners are able to send people to. If you're a partner, we will come and give you any one of these courses. If they're at Purdue, they're longer because we get to go out to S-BRITE. If they're at your facility, they're a little shorter because we can't go to the facility. Designing steel bridges for fatigue and fracture, welding in the infrastructure, which we do with Fish and Associates. Phil Fish has been really helpful and supportive of the center, as well as high-strength bolting that we do with Fish and Associates. And Phil helps us with our fatigue course. But I'm going to focus on that second one, implementing effective retrofits on steel bridges. That's our newest course. We've had some issues in Indiana where some fatigue retrofits maybe weren't the best selection. It was maybe a lack of understanding of some of the retrofitting strategies. And there's some research that's been done to kind of maybe update on how we would do some of the fatigue retrofitting. And so the thought was, well, let's have a course focused on that. But we don't want to just do death by PowerPoint. And so one of the neat things, and I know there's some people here who have taken this course, that you get your own specimen. So this would be like a hone bridge retrofit where you have intersecting welds. And you have to fix it. You have to implement the retrofit, and you are graded on the quality of the retrofit that you do. And so, the students are out there and they're working. So we spend time in the classroom, then we go out and implement a retrofit. Now, right now, INDOT's the only folks who've been pretty much taking it because we, contract-wise, we're running them through it. But the objective would be to put this then out on the street for other individuals. We've got a lot of interest in this right now. And there's a whole series of different retrofits then that individuals would go through and take. So it's kind of a fun course. We did 2 beta versions of the course to kind of work the bugs out. The first group, I thought some of you may know Merrill Doherty, and I thought we were going to kill him because we had way too much to do. The second course, we wore some people out. I think the third one now is a little more manageable with the type of retrofitting that you do. One of the other aspects is this idea of the DEN, the Distributed Expertise Network. And this has been also quite successful, I think, where states who are partners have access to a group of individuals. You know, at least the states I'm familiar with, you don't have the budget to have the welding expert, the coating expert, the fatigue expert, and all this. And sometimes you don't want to reach out to some expert, maybe at a university, because you don't want to bother them or you're not sure you'll get a response, whatever it might be. Well, we built what we call our den, and the den is like, you know, that room where the smoking jackets are and all the books and all the experiences in the den. And the idea is if you're a partner, you get to pick up the phone and call, you'd probably call me and then I'd route you to somebody where you get access to a certain set of individuals. And really we're moving their research into practice. And so right now we have a list of individuals. Like I said, the pooled fund partners have access to the den and a whole series of topics. And so here's our list of individuals that have agreed to be part of this with us. And short of me, it's really a who's list of people you'd want to have access to. So like with coatings issue, Bob Kogler is a guy I would always call. Or you want to get a hold of an NDE issue, well, Glenn Washer, Todd Helwig, Carl Frank. Right, we have really good people on this that are more than happy to help with specific problems. Now, generally they'd be short, right? These are going to be a couple hours at most. And if it turns in that you need more, then we have you now in touch with someone who then you can work with separately. One of the little things that's on the website that you can take a look at is Federal Highway wanted us to put together a steel property archive. We have a lot of material test data that I've had over the years myself that I've gotten from John Fisher. And so say you have a bridge from 1942 that has A36 steel and you're wondering what kind of toughness you might expect, you can go in here and kind of search through material test data that's available. And so it's you know, you don't want to hang your hat on it, but it gives you a feel for what you might have. What I would say is if you have projects where you've done this on older steels and you're willing to share it, shoot us an email, we can get it in the database. And we put it into a certain format so it's somewhat searchable. But that's been very useful for us lately. One of the specific studies I'll talk about is this POD. So this would be an example of a research project, probability of detection. And this is one I'm working on a lot with Glenn Washer. So you have this riveted structure. I don't think the structure exists anymore. I always say that, so this isn't anybody's specific structure. But the probability of finding, say, a fatigue crack at one of those rivets, right? And so we spend a lot of time looking for things, and we have no data that would say what's the likelihood of finding a 1-inch crack at a rivet hole or at a weld toe or an out-of-plane distortion crack. And so what we did is we built our test bridge. And in there, we took all the exciting details. So you imagine on a plate girder, between panel points, it's just web to flange weld at most. That's kind of dull usually. So we kind of compressed that down. And this represents about 450 to 500 feet of 3 separate girders with a painted span and a weathering span. Now you can't get caught up that there's a negative moment region or anything. It's just details. But in here, there's details that are riveted that may or may not have cracks. We have cover plates that may or may not have cracks. And out-of-plane distortion details, apparently there is a crack, right? These are all real specimens that have real fatigue cracks in them that we have the treasure map for, of different sizes, different locations, and so forth. And what we do is bring inspectors through. And it isn't to find fault with inspectors. It's not at all to do that. The objective is to try to figure out what is it that we're missing, and how do we tie that in then to the risk-based inspection strategies that I'll talk a little bit about coming forward. And then is there some training that we could do or simple tools require, maybe a certain type of flashlight or family of flashlights, that would improve this detection, or that you need a magnifying glass. You know, one of the things we found is a lot of inspectors who come through have never seen a fatigue crack, or at least a confirmed fatigue crack. And that's okay, but until you really know how to look for a fatigue crack at a cover plate, I can tell you the data would say that it's pretty unlikely you're going to find one of those. And so again, it's not intended to find fault. We really want to try to figure out how do we do this better, especially in the context of risk-based inspection. So one of the projects, this is kind of neat with the center, is now it's a place that we can partner with other projects. So Glenn and I are working on NCHRP 12104, and part of that is to improve the reliability of element level data inspection, rather. But we have specimens that we have known defects, and we can use the facility for that, right? And so we're going to be inviting some folks in to do some work on that. One of the questions we get is how do states get involved? Look for TPF 5281 if you go to the Pooled Fund website. I would encourage you to ask the partner states or people from those states what they think, because it seems we've had great feedback and many of the states are continuing to support. Now, you can participate in the traditional fashion, and what I mean by that is there's a certain fee for a certain level of support. You can come to our training. We will come and offer you training. You get kind of a seat at the table when we're laying out research and the DEN support. But I think one of the things that's really neat, when we developed this, it was specifically intended for partner states or other states if they have a specific task they're interested in. So I'll give you an example. MnDOT is a normal partner, right? They come and we do training and we work with them. But they also had a specific need related to the Winona Bridge, some testing that needed to be done on some big trust members. So they were able to carve that out as a separate S-BRITE task. Now what's nice is S-BRITE exists, that pooled fund study exists. So we don't have to go through all the contracts and all the rigmarole with that. It's a special task within the center, just with a unique scope. Another one, Wisconsin. We've been doing a lot of work with Scott Becker. Now, they're not a full partner state, at least not yet, I hope they'll join. But Scott had a specific need related to fracture critical bridges. And so what we're able to do is very easily and seamlessly, he can become a partner for a specific task. And what we're looking at is some modeling on several twin tub girder bridges for him. And what we hope to do is to be able to take a lot of these off the fracture critical list by applying the 2012 memo from the Federal Highway. And I can say we've already gotten one bridge approved. And that was our beta bridge to make sure our process was consistent with what the feds want. And now we hope to roll through on a bunch of other bridges and get several off the fracture critical list. The other project, though, that now we are proposing, so they're existing ones, special tasks, but one that working on with Glenn is NCHRP 782 is the project that some of you might be familiar with that he led that was looking at risk-based inspection. And if you know, MAP 21 is requiring that. One of the things that we think would be very good to do is try to standardize that, take that research and make it into more of a standardized approach so that every time a state goes to the feds with their procedure, it isn't being reviewed separately and coming under scrutiny and that there's 50 different approaches. Now, while the approach is specific to states, this would allow us to have kind of a standardized approach and very good guidance available on how to do this, so that when this becomes available, because it looks like, you know, it's required by the MAP 21, the state would be able to hit the ground running. Now, we've started this in Indiana. We're already trying this out so that when it's available to be able to be used, we can say, ta-da, here's our risk-based approach on how to do bridge inspection. And so the goals would be to have, you know, a handbook available, what methodologies, how do we tie this into preservation and so forth. And one of the neat things that I think that Glenn had a neat idea with is, you know, there's a lot of talk of UAVs. Well, how does that work in then to this new framework of inspection, right? And so this may be someplace we're partnering with S-BRITE in terms of overall reliability or UAVs or different technologies. How does that play into this new method of setting inspection intervals? So kind of a neat project. So for costs, estimating, we'd like people to at least make a 2-year commitment in the $50K per year approach. Looking at least 6 states and be part of the pooled fund. And again, talk to Glenn. And then another little project I'd like to just share is some things we're doing that if we have some interest in on 3D imaging, where we just use photographs to measure corrosion and damage in girders. An exciting one, and I'd be happy to answer any questions on that, where we can just take pictures of things and measure corrosion and damage. And so in summary, we've got a lot done in 2016. Our training is going to continue. Look at our website for that. We look to develop a partner program with industrial, with consultants and so forth. And I do want to acknowledge everybody who's been very supportive of the center, as well as on the professional side or on the industry side. So check us out on the web. Again, there's a lot of things going on, and our training calendar and so forth is always getting updated. And just take a look, and we're excited, and if I can answer any questions, I'd be happy to try to do that. So, okay, thank you.
Feel free to talk. Are you going to be around?
I'll be around.